This assignment aims to help you understand shapefiles of different spatial features and their attributes. It enables you to edit their attributes and calculate the area, length, and count of the features. This assignment aims to achieve 7 objectives. 1. To open a vector file or shapefile in QGIS. 2. To understand the line, polygon, and point feature classes. 3. To create a new shapefile from an existing one. 4. To understand overlay operations such as clip. 5. To understand the attribute table. 6. To edit the attribute table. 7. To find the area, length, and count of the features. We shall address the steps in detail. First of all, we shall look at the data provided to you for the assignment. Download the data folder from the Taxila portal and unzip it. There is a Word file for submitting your work and an Excel sheet containing details of the datasets assigned to each student. The folder also includes 4 sets of shapefiles representing districts, roads, villages, and water bodies. Here we're going to use shapefiles as input data. A shapefile is a popular geospatial vector data format used in geographic information systems, GIS, to store the location, shape, and attributes of geographic features. Although we call it a shapefile, it actually consists of multiple files that work together, all having the same name but different extensions. For instance, a shapefile named village might include multiple files with same name but different extensions. Open QGIS from your Start menu. Go to Layer, Add Vector Layer. Navigate to the folder containing the data files. Select the district layer, the file with the type AutoCAD Shape Source, and click Open, then Add. You will see different district polygons displayed on the screen. The rectangle symbol in the Layers panel indicates that it is a polygon shapefile. Similarly, we can add a line feature layer called Roads. The procedure remains the same. Make sure that you always select the AutoCAD Shape Source file. The line feature class shows a line symbol in the Layers window. Next, we shall add a polygon layer called Water Bodies to the current view. The procedure remains the same. Finally, we shall add a point layer called Villages to the view. The layer window represents the point layer as a dot. Now we have learned to open 4 datasets given to you. The datasets are districts, roads, water bodies, and villages. Now you have completed the first task of opening shapefiles in QGIS and second task to understand the point, line, and polygon feature classes. The third task in the assignment is to create a new shapefile from the existing district shapefile. This is done because each student is required to work on a specific district dataset instead of the entire dataset. The district assigned to you is listed in the Excel sheet provided in the data folder. Open the Excel file to view the details. Each student has a separate district to work on. For example, I have been assigned the Mulugu district in this case. Before proceeding with the extraction of the district from the main dataset, you need to create an output folder inside your data folder. All your output files will be stored in this folder. This folder will be submitted for evaluation at the end. Now, go to QGIS and select the district shapefile. Right-click the shapefile and choose Open Attribute Table. The attribute table displays a list of all the districts. Click on the district column header to arrange the contents in alphabetical order. Then search for your assigned district. In my case, it is Mulugu District. Select the district and click the zoom icon, represented by a magnifying glass. Minimize the attribute table, and you will see your district highlighted in yellow on the map. Next, we will extract this district into a separate shapefile. Right-click the district layer, select Export, Save Selected Features As, browse to your output folder, and name the file with your district name. Click Save, and a new layer will appear in the Layers panel. To avoid confusion, remove the original district layer from the Layers panel by right-clicking it and selecting Remove Layer. The new shapefile will now be available in your output folder. As of now, we have completed the third task. The fourth task is to extract or clip the other layers, namely road, village, and water body, using your district layer. Select your district layer, then go to Vector, Geoprocessing Tools, Clip. In the Clip window, the input layer refers to the layer that will be clipped or extracted. We will now clip the road layer. Set the input layer to road and set the overlay layer to your district layer, which defines the clipping boundary. Specify a file name and save it in your output folder. Then click Run. A new layer named Road Clip will appear in the Layers panel. To avoid confusion, remove or close the original road layer from the Layers panel. Next, we shall clip the village layer also. Name it as Village Score Clip. Click Run and Village Clip layer appear in the layer window. To avoid confusion, remove or close the original village layer from the Layers panel. Next, we shall clip the water bodies layer. Name it as Water Body Clip. Click Run and Water Body Clip layer appear in the layer window. To avoid confusion, remove or close the original water bodies layer from the Layers panel. Open the Output folder and check that the newly created 4 shapefiles, along with their supporting files, are present in the folder. Now we have completed the fourth task also. Next task is to understand the attribute table. Attribute table is a table that stores descriptive information, or attributes, about the features in a spatial layer. Each row in the attribute table corresponds to one feature, such as a point, line, or polygon, and each column represents an attribute or field describing that feature. Now open the attribute table of the clipped road layer. Each row in the attribute table represents a line feature corresponding to a road segment. Each column or field provides a description or attribute of the respective road. We shall open other attribute tables also to see their contents. As of now, we have completed the fifth task. The next task is to edit the attribute tables. In this task, we will open each attribute table and add a new column or field to it. First, open the attribute table of the clipped water bodies layer. To edit the table, you must enable the editing mode by clicking the Toggle Editing button. Next, click on New Field and name it Area. This will create a new column with the header Area in the attribute table. To make the changes effective, save the edits, and before exiting, be sure to turn off Stop the Editing mode. Close the attribute table and open another one. We are not going to edit the clipped village file. Open the Road Clip attribute table and enable Toggle Editing. Select New Field. Name the field as Length. Save edits. Disable Toggle Editing. Close the attribute table. Next, we are going to edit the attribute table of your district file. Open the attribute table and enable Toggle Editing. Select New Field. Name the field as Area. Save edits. Disable Toggle Editing. Close the attribute table. We have now completed the sixth task. The final task is to calculate the area and length of the features in your shapefile. Open the attribute table of the clipped water body layer. Click on the Field Calculator icon. This will automatically switch the table to editing mode. In the Field Calculator window, select the Geometry options and double-click $area. Then check the box Update Existing Field, and from the drop-down menu, select Area. Click OK to calculate the area of all the polygon features, which will now be populated in the attribute table. Don't forget to save the edits, then disable the editing mode, toggle off, and close the attribute table. Similarly, we can calculate the road length also. Open the attribute table of the clipped road layer. Click on the Field Calculator icon. This will automatically switch the table to editing mode. In the Field Calculator window, go to the Geometry options and double-click $length. Check the box Update Existing Field. From the drop-down menu, select Length. Click OK to calculate the length of all road segments, which will now be displayed in the attribute table. This is a possible mistake you can make. Here, one feature is selected, and the calculation is accidentally done for that feature only. So, we need to deselect the feature. For that, click Select All and then Invert Selection. Now, nothing is selected. Do the same procedure to get the length. Make sure to save the edits, then disable the editing mode, toggle off, and close the attribute table. You can find the area of the district also. Open the attribute table of your district layer. For me, it is Malugu district. Click on the field calculator icon. This will automatically switch the table to editing mode. In the field calculator window, go to the geometry options and double-click $area. Check the box Update Existing Field, and from the drop-down menu, select Area. Click OK to calculate the area, which will now be displayed in the attribute table. Make sure to save the edits, then disable the editing mode, toggle off, and close the attribute table. Now we shall find the total areas and lengths of the features. For that, click on the Show Statistical Summary icon. From the Statistics panel, select the road clip layer and note down the total length. Similarly, find and record the total village count, the total water body area, and the area of the district. Keep these values to write down in the submission sheet. Now we shall see the instructions for submission. Zip the output folder and upload it to Google Drive. Remove any access restrictions, then copy the shareable link. Paste the link in the Word file. Fill in the Word file with the noted statistical values. Write your name and ID and submit it.